So in class we did this example where we found the 5 points that we needed to help plot the sine function displayed here. So that would be this one right here. Let's try that again. This one right here. And you know, it's a challenge to find these 5 points. I understand that that's the hardest part about this method. The idea is to take the argument of the sine function and put it between these two values, 0 and 2 pi, and then solve for x. That gives you points 1 and 5. And then the rest of these points, 2, 3, and 4, are just averages. So if I average 1 and 5, well, then I get the middle one, which is 3. 2 is the average of 1 and 3, and 4 is the average of 3 and 5. Now, a lot of times this becomes kind of annoying because these values don't work out nice and even, and you have to deal with fractions. Mostly it's to deal with fractions. So let me show you another approach to trying to find these values. So let's scroll down a little bit, and now I guess we're going to go right here. So that other approach is when you have your argument, instead of setting it between 0 and 2 pi, you're going to have to rewrite that in terms of its equivalent angles in degrees. So pi over 2 is a 90-degree angle, and 2 pi is 360 degrees. 0 is still 0. If it's in degrees or radians, doesn't matter. So we'll rewrite this in terms of degrees, and then we're going to solve everything in degrees. Now that's going to make life a little bit easier. I think most people would prefer not to have to deal with fractions. So we'll subtract 90 from all three sides of this inequality first, then divide by 2, and that gives you points 1 and 5. Now, as far as the rest of the points, it's just like it was in the previous example. That is, we're going to start out by averaging points for 1 and 5 to get 3. So when I do that, I get 45 degrees. When I average points 3 and 5, then I get our fourth point. So that happens to be 90 degrees. And last but not least, 2 is the average of 1 and 3, and I get a 0. Now, on the test, you're going to be graphing these things in radians. So the thing to do is to take these angles in degrees and convert them to angles in radians. So let's review that, and kind of a nice helpful way to review that is to look at it on a calculator. So let's go over to our graphing calculator right here. And suppose that you're playing around with something and you end up with an angle of 22.5 degrees. And like, well, what is it as a fraction? Because I know he likes it as a fraction. Well, to convert, remember you're going to multiply by pi over 180. Here's the trick. Don't use the pi, at least not yet. Let's just multiply by 180, or 1 over 180. So times 1 divided by 180, or I simply could just divide by 180. And that's going to give me a decimal. Now maybe you're not really all that hip on all these decimals. You're like, well, what is that? You know, okay, hey, I get it. But here you go. You hit the math key, and then you press enter twice, answer a fraction, and boom, you get 1/8. So the answer for us then would be pi over 8. Similarly speaking, if you say had 30 degrees and you want to convert that to radians, I'll multiply by 1 over 180, and then hit the math key. That's 1 over 6, but remember we have to include the pi there, so that's pi over 6. So it's a different way to work on trying to find these angles. It might be a little bit more user-friendly. It's up to you what you find helpful. Once you find those angles, what I like to do sometimes is write everything in terms of the same denominator. So if I convert pi over 2 to an equivalent denominator of 4, then look what the nice sequence of points I got. Negative pi over 4, 0, pi over 4, 2 pi over 4, 3 pi over 4. So not only are they nice and evenly spaced, it's going to help me graph this, but it's also a double check on your work because you know you got this thing right. All these things are nice and evenly spaced. That's your X. That's 4 points out of 10 right there. If you stopped and did nothing else, you get 4 points right there. But hopefully you'll move on because the rest of this is not too bad. If we apply the argument, that is take 2 times x plus pi over 2, you're going to get this part automatically. You don't even have to think about that. And then as far as cosine, well, cosine is going to give me this here. And again, that's not something you need to really even think about. And then negative 3 times that, that's the last column here, that gives you your y coordinate. So you've got your x coordinate right over here, you've got your y coordinate here, and you can come down and graph those. Here's where it's nice to have everything nice and evenly spaced, so you know how to lay out your tick marks, and then you know how to extend your graph too. So when you extend your graph, well, just keep on moving by units of the same tick mark. Pi over 4 to the left, pi over 4 to the left again, etc. Notice I don't put these in lowest terms. I just kind of leave them as they are, and that's fine. I'm very, very fine with that. So here's our first period right here, and then you repeat that to get the second period, and now you get all 10 points out of 10 on a problem like this. Good luck on these. We'll see you this week.